Hello. After a quite a bit interval, we are again on 30th November. So at this time, we are being very busy in our fixed schedule of taking regular classes, arranging mock tests for class 10 and class 12, which some of you know very well. So there has been a bit delay between the videos, but today's brief lecture is about on radioactivity. Some of you has had requested me to take a lecture on radioactivity. That's why we are taking this lecture on radioactivity. So what is radioactivity? So before going to that, radioactivity, the phenomenon was discovered by Henry Becquerel. You know that, at least some of you, or you should. So before going to that, we have to again just take a backward step towards the atomic structure. Repeatedly, I said in my regular classes also that atomic structure is the base of physics. Now the root of radioactivity is atomic structure again. What does it say? We all know that inside the nucleus there are protons as well as neutrons and some subatomic particles, many subatomic particles actually. So, but we will focus on protons and neutrons for basic classes. Inside the nucleus and outside them, the electrons are revolving around the nucleus in some certain orbits. Fine. So, and the stability of the nucleus is a question. Why, sir? Because protons are positively charged. They are living inside the nucleus, which is a very small place. How is it possible, sir? Why the nucleus should have burst out? Because there are plenty of positive charges. There should be a huge repulsive force acting between the protons, resulting in the bursting of nucleus, instability of the nucleus. But actually, this does not happen. Why, sir? Because we say that very strong force, probably the strongest force in nature, nuclear force, acts inside the nucleus, which binds the protons inside the nucleus. But this is actually a bit questionable. What is the origin of nuclear force, sir? Now, then we say that there is a subatomic particles known as pi meson particles. Due to the relentless exchange of these pi meson particles, protons are being converted into neutrons and neutrons are converted into protons, vice versa. So the total number of nucleons, that is sum of protons and neutrons, remains constant, remains fixed. There is no question about that. But there is no fixed proton or neutron inside the nucleus. That's why the attractional force or the, you can say, the repulsive force between the protons is also not fixed. That is the mystery behind the stability of the nucleus, you can say. But this has a limit. We say that when atomic number is greater than 82, lead, 82 is the last stable element or nucleus. Beyond 82, when the atomic number is greater than 82 or neutron-proton ratio is greater than 1.5, then the stability of the nucleus breaks. It becomes unstable. And what does it do? It releases energy. It releases some particle and also shear energy. Alpha particle, beta particle, they just emit spontaneously. This is a spontaneous change. It comes inside the nucleus. So it is a pure nuclear phenomenon. It is a pure nuclear phenomenon in which alpha rays, beta rays, they are the particles. Alpha, what is alpha? Alpha is nothing but helium nucleus. We say that alpha is like that, 2He4. It is nothing but helium nucleus, means twice the unit positive charge. That means 3.2 into 10 to the power minus 19 coulomb, and it has 4 times the mass of a proton or mass of a hydrogen, you can say. And beta particles, this is nothing but electrons. But why said beta? It has a charge just like electrons. It has a mass, or you can say almost massless, just like electrons. But why did we term the beta? Because it is coming from inside. And there may be a question, sir, electrons from the inside the nucleus, how is it possible? So we are terming this as beta particle. These are nothing but highly energized electron and gamma rays, which are electromagnetic waves. So it continues to emit those radiation till the stability of the nucleus is regained, and no physical or chemical activities changes can influence these emission. Just we say earlier that it is a pure nuclear phenomenon and spontaneous emission, right? And that property is called the radioactivity, and the elements showing this property beyond 82 up to 118 discovered till now, they are all radioactive, right? A natural up to 92 they are natural, and after 92 transuranic elements, right? They are synthesized synthetic elements. That is another part we will discuss surely in some other classes. Now, after radioactivity, after knowing radioactivity, there is a very basic question: differentiate between alpha, beta and gamma rays. Alpha is positively charged, twice unit positive, beta is negatively charged, just like electron. Gamma is neutral. Alpha and beta are particle in nature, gamma is electromagnetic wave, right? EM wave, should write it. EM wave, electromagnetic wave, energy you can say. And penetration power of the gamma rays are maximum, so it can penetrate most, and alpha rays penetration power is least, beta is intermediate. Again, maximum ionizing power there is in alpha rays, beta has minimum capacity of ionizing a gas, intermediate, and gamma has least capacity of ionizing a gas. Alpha rays, they are positive, being positive in nature, they bend towards the negative field, beta bends towards the positive field, gamma rays remains undeviated by any interaction of any electric field or magnetic field. Again, you can say the capacity of destroying a living cell is most in case of gamma rays, least in alpha rays. That's why gamma rays are nowadays used a lot in cancer treatments to destroy those cancer affected cells, right? These are the differences. After that, there comes a very important basic law of radioactivity known as radioactive decay law. What does it say? It says that rate of disintegration, I repeat, the rate of disintegration of a sample of a radioactive element is directly proportional to the number of unchanged atoms of that sample at that moment, at that instant, right? I repeat, the rate of disintegration of you can say sample of a radioactive substance is directly proportional to the number of unchanged atoms at that instant. Now let us write it mathematically and see if we can get any mathematical expression from there. dN dt proportional to n number of unchanged atoms, or you can say dN dt equals to minus lambda n. So what is lambda? Lambda is radioactive decay constant. Lambda is radioactive decay constant. And why is there minus sign? Minus sign is for sample is decaying, sample is decreasing, right? Getting me? For that the minus sign. Now we just writing dN by n equals to minus lambda dt. So integrating, initially at the initial state, suppose n0 is the number of initial atoms, unchanged atoms of the sample, and after a time interval t it becomes n. So integrating, we are getting log n minus log n0 equals to minus lambda t, or other words log n by n0 equals to minus lambda t. From that we are getting that n equals to n0 e to the power minus lambda t. That is the relation between the number of unchanged atoms after a certain interval and the initial number of atoms. So we are just writing there n0 equals to initial number of atoms of that sample. Initial number of atoms of that sample. Getting me? initial number of atoms of that sample. N equals to, after time interval t, suppose n is the number of unchanged atoms at that instant, number of unchanged atoms at that instant, at a time, after a time t, suppose after a time t. That's it. And lambda is decay constant. Lambda is decay constant. Lambda is decay constant. That is the relation between n equals to n0 e to the power minus lambda t, a very basic relation. From that you can also write what is activity. The next question is activity. What is activity? Activity means dn dt. Activity means dn dt. That is minus, you can say dn dt equals to what, sir? Mod of lambda n. So activity is lambda n, mod of lambda n. Now from that you can also write that lambda n0 e to the power minus lambda t. N equals to n0, putting that. So you can also write now a equals to a0, putting a0 in place of lambda n0, a equal to a0 e to the power minus lambda t. That is the relation between activity at a particular instant to the initial activity. A is the activity at the particular instant and a0 is the initial activity. That is the relation between them. A equals to a0 e to the power minus lambda t. Okay. So, and then comes the unit of activity. SI unit of activity is what? SI unit of activity. In SI, the unit of activity is becquerel. You can say becquerel. Or you can also write disintegration per second. Disintegration per second. This is the SI unit of activity. SI unit of activity is becquerel, otherwise disintegration per second. Practical unit is something else. Practical unit is Curie. Practical unit is Curie, according to the scientist Curie, named after him or her, you can say. 1 Curie equals to 3.7 into 10 to the power 10 disintegration per second, or 3.7 into 10 to the power 10 becquerel. That is the relation between practical unit and SI unit. 1 Curie equals to 3.7 into 10 to the power 10 becquerel. So I think it's enough for today's class, today's short lecture about radioactivity. Hope it goes well for you. And if you have any remark or any doubt again, or you are interested in any other topic on any other you can say topic of lecture, you can request me, you can make any comment on that video. Thank you. Hope to see you again soon.